Oh, yes. Here it is. As early as I've ever seen it. It's not even June yet. But let's see what we've got in store for us today. Q-tips. And a pin header for, I wonder if this is for a pie or something like that. It is a pin header of some sort that is, it's, a pie cobbler. Must be a pie clone in here. Oh, yeah, look at that. Oh no. Some tweezers, yeah, gotta have some tweezers. Yes, here we go. Here's some pie stuff. USB to USB. HDMI to HDMI big. A USB charger. Jumper wires. A Raspberry Pi Zero. And oh my goodness. Okay, so we are going to get good at soldering surface mount. Or we're going to cook up a little reflow oven somehow. Interesting. Interesting. Is that a preloaded noobs disc, I wonder? And what do we have? Oh yeah, of course we've got to hook it up to a battery. A RetroPie. Nice. Raspberry Pi Wi-Fi. There's the pinouts. Here's a little guide to SMD devices. 0201, 0603, so your imperial. That tells you how many inches it is in length, width, and height. They don't have height on here. Very good. And then all of the different surface mount package types, all with various measurements. So a nice little reference card for your surface mount devices and a nice little reference card for the pinouts on the Raspberry Pi Zero. Very nice. I'm sure we can find some fun stuff to do with that. I am sure we can. Okay, so this gives you a way of breaking out on a breadboard the Pi. So you've got your ribbon cable that plugs into your Raspberry Pi, which is over here. Does it have pin headers? Do we have to solder pin headers in? Yeah, we have to put pin headers in. But so that will go there. That goes into the breadboard, and so now you can do some prototyping rather than doing jumpers off of the Raspberry Pi. So yeah, easy peasy. We also provide a bit of flex strip for, I think that's for the camera or the display. I forget which, but in any event, these little connectors, you just pull the gray part out just a bit, and then you slip them into the connector like that, and then you clamp them by pushing that down. And then that provides a mechanical force that presses the conductors down onto the circuit board. And so that is, I believe, let's see, the USB, HDMI. That's the, so this must be for the camera module, which we don't have. But anyways, they include it in the package for you. So yeah, that's that little bit. And then that is, this I think is a NeoPixel board, so you can interface to it. We can get it to spin around and do all kinds of funky stuff. But yeah, that'll be fun. We got a whole bunch of LEDs to solder on there. There's probably some diodes. Yeah, those look like diodes. There are probably some resistors and capacitors and some transistors and a little, probably a microcontroller. microcontroller, and maybe a voltage regulator of some sort in there somewhere. Are there any 3-pin devices? No. But there are some small ICs along here, which probably are shift registers for doing addressing of your LEDs. Sorry, yeah, no, not NeoPixels, because there's only two terminals for each one. These are probably just plain old LEDs that are driven through software. So yeah, I guess we should get started on building this little jobby, because that is going to take some time with the solder. It might just be a job for solder paste instead of solder, so I might have to get the solder paste syringe out and do it that way. Anyways, we'll see how it goes. Okay, so what do we have on the board here? We've got +5 in, we've got a couple of pin headers on either side. Then around this circle we have resistors, diodes. So that would be the current limiting resistor for all the diodes. And then we have 1, 2, 3, 4, 4 diodes through here. They're not light emitting, I don't think. Those are just regular diodes. Then we have some resistors and capacitors and resistors along here. A couple of resistors, D19, D8, a couple more diodes. There's a transistor that goes there. There's a transistor that goes there, transistor there, and then some more diodes and resistors along the top. That's on the top side. What's on the bottom side? On the bottom side, we have a bunch of, I don't know, those might be pad contacts. What do we have here? Well, this is interesting. We have some 2-terminal devices here with some through-hole, with some filled vias there, and then we have a bunch of these chips in some sort of cascade or some sort of bus arrangement. No, don't know what those are doing. Something tells me I'm going to have to find some instructions on this somewhere. This might just be a board for practicing your soldering skills on the back side here. I'm not 100% sure. But let's take a look at what parts we've got. Those look like they're LEDs because of that little bar there. Those look like diodes because of the black bar. Surface mount diodes. What is this chip? Can we read it? I might just have to get a magnifying glass out or a microscope. Oh, here we go. Here we go. HYC 5 volt. I can't quite. Oh, there we go. 5J98W. CD 4017BM. I'm pretty sure that is a shift register, so that operates on an SPI bus. Not 100% sure, but I think that's how you get information into, it takes in a serial data and then it splits that serial data out into parallel. Here, what looks like more LEDs. Yeah, definitely more LEDs. LEDs. These are either transistors or voltage regulators. Gosh, hard to see. Yeah, definitely gonna have to get a microscope out to do any of this. Here is a tiny IC. What is this? Oh my gosh, it's a 555 timer. Some resistors. Some more resistors. Where are all of our capacitors? There. 2 capacitors. That's all we got? Did I Am I missing something? That's not all of the parts for all of this board here. I wonder if I'm missing something. Anyways, off to find some instructions, I think. Off to find some instructions, unless some of these might be capacitors. Anyways, let's go see if we can find a mapping between the component numbers, like R53 here, and component values, which are on our devices here. Okay, here's our bill of materials. We've got a timer IC, the 555 timer. We have a counter, a CD4017, so it's a probably an 8-bit counter. Then there's 4 transistors, NPN Jelly Bean transistors, a bunch of 470 ohm resistors, and then 6 10K resistors, a 2 mega ohm resistor, 2.1 microfarad capacitors, probably filtering for pins on the ICs. Then we have some red LEDs, some plain old diodes, and then some blue LEDs. And that's all that's in the bill of materials. Now, where does all that stuff go? We've got quantity ones, we've got the package type, and we've got the reference number, so we can just read off the reference number on our board and plonk the various devices down after figuring out which one is which. And the way we figure out which one is which is by, well, either measuring them, if they're resistors they're easy enough to measure, or get a microscope out and try and read whatever markings are available on them, which are probably going to be scanned. But anyways, let's give that a shot. So I'm borrowing my daughter's STEM box microscope that came a couple of months back, and we'll see if we can use it to get information off of our chips. Okay, so those have a 471 on there. So what that means is 47 and 10, 470 ohms. So these are the, well, 470 ohm resistors. What do these guys have on them? Let's try and poke those under there gingerly with our tweezers so that they're underneath microscope. What do we have there? We have a 103, so that's a 10 with 3 zeros, 10K, 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 10K. What is that? 5 10K resistors? 5 10Ks, yeah. And what else do we have? We're supposed to have some capacitors. These will be unmarked, I'm pretty sure. Yeah, those are unmarked. They're brown. They're capacitors. These are the diodes, regular straight-up diodes. They are unmarked, but they look like a diode. And then these are the transistors. I don't think that they'll be marked. And if they are, I don't know if we'll be able to. No, they might be marked. Let's just see. If there is, oh yeah, there we go. There's some sort of a marking. But it's hard to read. J3Y. Only of significance to the manufacturer, I'm sure, without some sort of a other way of understanding it. But holy smokes, that thing's tiny. Tiny, tiny, tiny. And then we've identified other 2 ICs. We've got a couple of sets of LEDs. So you can see on that little guy there that there's a pad and a whisker. That's the LED mechanism inside there. So what we're going to do here is we're just going to lightly dab some solder paste on all of our pads and use that as our as our solder. Soldering paste has both flux and solder in it. And we are going to then place our components and then apply heat to the components, and that will form our solder joint. So we are starting with our resistors. So let's get our tweezers out and start plunking down our components. Resistors are not a polarized device, so we can just ignore. Well, those are tiny. Oh, dropped one. It's down there somewhere. Probably upside down somewhere. Okay. Another resistor. That is totally going to be the big risk with this thing, is losing components as you're assembling it. So just be careful. Don't be like me. Be careful. Because I think I already lost one. I might have some extras kicking around. It's possible. I won't say like, oh, there it is. Found it. I don't think I got enough solder paste on that pad there, but it will provide a little bit of adhesion. Not a lot, but a little bit. Wow. These things are tiny. Tiny. Tiny, tiny, tiny. Now, it's pretty important to get a nice clean, should I just, yeah, no, it's fine. A nice clean tip, and it's also important to hold your devices down a little bit while you apply the heat. Wow, I am shaky. And that's all that's needed. Yeah, there. That was the right amount of paste. I think I'm starving my other joints a little bit, I think. Yeah, that looked better. Oh, come on. You can do it. There we go. Oh, yeah, that looked good. I think that's all of them. And then we can just go around the other side. Let's clean that tip up a bit. Yeah, that one was good. That one's good. That one's good. Maybe okay. Maybe okay. That one's good. That one looked alright. That one's probably fine too. But I think I'm going to have to go around and add a little bit more solder to some of these because they don't quite have enough solder. So I'm going to go rework those a little bit, and we'll be back. Or actually, maybe I can show that. I don't know. Is it going to be too boring watching somebody solder all night? I had a thought about doing a soldering video where there was music in the background and people could just groove on that, but I don't know. Really. There we go. That's more like it. Ow. So what I shoot for is something that looks like that. A nice little fillet around the base of the device. That's even a better one. Not too much solder, just enough to make sure that you're attaching a nice little fillet. That's probably too much solder on that one, but that's not the end of the world. That's probably the ideal amount of solder right there. And yeah, just enough to tack the device to the board, not so much that it flows over onto other things, and a nice little fillet that forms a curve from the board up onto the device. That's what I go for, and it seems to work. And so there's a reasonably crappy job of soldering the transistor on. Let's try some of the other transistors, see if we can't improve on that. Which is anode and which is cathode. So here's +5, here's minus. It's going to that pin, and then you follow the trace along. It's going to that pin, follow the trace along. So the cathode side is out. So we want the power on the inside and the cathode on the outside. And that's how we orient these little specks of fly turd. But seriously, you say, is that actually how we're supposed to, that's seriously how we're supposed to do that? Check them every time? No, because on the backs of these guys is a T symbol. And you remember that the voltage is flowing, come on. Come back here. If you look at the back, then they got a little T symbol. Oh, come on. There we go. And you orient them so that that T symbol, if you imagine the short leg of the T is being the direction that the current flows in. So the current flow should be that way. And indeed it is. Yeah. So the direction of current flow is in that direction. If the T goes like that, the current's flowing that way. Okay, let's see if we got those plugged in the right way. Should not get any brightness that way, but we should get some brightness that way, and 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 that way. And that way, and that way, and that way. And, hey, what's going on with you? Are you, oh, you might be starved. I might have to check that solder joint. Okay, well, let's take a look at that. And sure enough, that one does look like it doesn't quite have enough solder on it. So I'm just going to put a little bit more solder on that one. Okay, what does it do? +5 goes in there. Oh. It does a bunch of things. It moves the hands around the clock. 1, 2, 3, 4, 5. Yeah, and it blinks the middle LED and it blinks the outside LEDs. So, well, there's that. Okay, a couple words on tools. A nice set of tweezers, great for surface mount soldering. If you're going to be doing any fine work, I use, well, I'm a lead solder kind of guy. The fumes from the flux is probably more dangerous than the lead that's in the solder, but your mileage may vary. This stuff that I use is 0.4 millimeters when I'm doing surface mount stuff. I have some, what is this? 0.8 millimeters, so it's twice the gauge of this for soldering through-hole components. This is the solder paste I was using. I think it has the similar, if not the same, ratio. Yeah, 63:37 with 25 to 45 micron thickness is what you're supposed to apply it. So that's what they mean by that is if you're going to be getting a solder mask built for a board, which is either a stainless steel or a polyamide sheet that you set over the board, and then you just scrape solder paste across it, and it fills up the little void that is made by the solder mask, or sorry, by the stencil. That's the thickness of paste that you're gonna need, and yeah, that's what I use for solder. I have some liquid flux that I use in my syringe for applying little daubs of solder. These guys, 5 of them come for $1 if you wait for a month on eBay. And then I have a syringe that has as an applicator for solder paste, and it's just press, 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 dab, 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 and you keep dabbing up and down until a little dollop of solder comes out. I mean, it's a experience / judgment kind of thing. So yeah, for a soldering iron, I have a super cheap Wacko knockoff. Wacko. Got that again off of eBay. It's not. It says ESD safe on the base, but I do not believe that. So I'm a bit careful, and I don't trust the temperature gauge on it. I use the ability of the solder to melt as a gauge of what the temperature is, but gets the job done. I have used in the past an adjustable temperature gauge soldering iron as well, with a fine tip. That got me through quite a bit of soldering as well. It's got an adjustable temperature, and it's got a replaceable tip. I think it uses something like the Wacko tips, but they're a bit different in dimension. I think these are wider. But if I have like big things to desolder, like a heat sink or something like that, I will pull this baby out. But you know, it's temperature adjustable. It's got a grounding clip. It's been usable, and it was $15 on eBay. So not like you're going to break the bank getting yourself one of those either. The 936 knockoff was, I think, $60, which I paid too much for. But yeah, you know, do what you can. I also have some solder flux paste, and I use that to clean the tip off, because you want to have a relatively clean tip that takes tinning quite nicely. So get that out of the way. So you want to be able to tin the tip up, and in order to do that, you need to actually knock some of the yeah, that's getting more like it. So yeah, that's the kind of tip you're looking for when you want to have that constantly, because that provides you with the best heat transfer right there. Looks something like that. Nice and shiny, takes solder very nicely, doesn't ball up too much, and yeah, that's a little rundown of the tools that I use in order to get the hacky job that I have that seems to work, but you know, could be prettier, but that's all there is. Anyways, thanks for watching. Bye for now.